of soil. So at first we have to know that what is liquid limit. But before knowing what is liquid limit, we have to familiar with some term, that is what is consistency of soil. So scientist Aterburg says that the consistency of soil is basically the flowability of soil. So flowability means the ease of flow by which the soil can flow. So scientist Aterburg defines some limits, and he defined a graph between the volume of soil, which depends on basically the water content of the soil. So there is 4 different phases of soil. First is solid, then semi-solid, then plastic, and then liquid. So as our topic is liquid limit, so we can define liquid limit as the phase when soil changes from plastic to liquid, or rather we can say liquid to plastic. So corresponding water content is called liquid limit. Okay, or we can say the minimum water content at which the soil is in liquid state is called liquid limit. So in liquid limit, the shear strength of all type of soil is same, and it is 27 gram per centimeter square. Okay, so this is another type of definition of liquid limit, that the water content at which the shear strength of soil is 27 gram per centimeter square is called liquid limit. So how we can determine liquid limit in our laboratory? So we can determine the liquid limit in our laboratory by Cassagrande apparatus. Cassagrande apparatus. Basically there is a Cassagrande tool we can easily see in our lab, and we give the number of flow at which there are 2 parts of the soil. We can cut the soil in 2 parts by a Cassagrande grooving tool, and at which water content after giving 25 number of blow, these 2 soil can attached by at least 1.125 centimeter. 1.125 centimeter means this length is at least 1 to 1.125 centimeter is called the liquid limit of the soil. So how we can determine the liquid limit of the soil? Then we have to go to the lab. So the required apparatus for the liquid limit test of soil is at first the soil, which is generally passing through the 425 micron sheet, or we can use the 600 micron sheet. This is the 600 micron sheet which is used in this test. This is the pan and this is the measuring cylinder for measuring the water which is used to mix with the soil. This is the secondary apparatus. This is the grooving tool, and this is the weight machine to weight the soil sample. This is the soil passing through the 600 micron sheet. So we take 300 gram of soil. So at first we tear this pan. Now we take 300 gram of soil which is passing through 600 micron sheet. So approximately this is 300 gram soil. So now we have to add water to this soil up to a certain limit. So we start with 10% of water content, and we take approximately 10% of water of 300 gram. So approximately this is 30. So we take water. So this is approximately 30 ml of water. So we add this water to this 300 gram of soil, and we have to mix this water with the soil. So during mixing, it seems to require more water to the soil as its liquid limit is higher. So we add more 5% of water, that is 15 ml of water to this soil. So this is approximately 15 ml of water. We add this water to our soil sample. And again we mix properly this water with this soil sample. So during mixing, it is visible that the soil absorbs more water as it is passing through 600 micron sieve. So we add another 5% of water, which is 15 ml. So let's mix another 15 ml of water to this soil sample. So initially the soil sample has been prepared, and the total water content mixed to the soil sample is 20%. Initially we have add 10%, then couple of times we add 5%. So total 20% of water has been added to this 300 gram of soil sample. So the soil sample have been prepared and we fill the soil sample to the Casagandre mold. This is the Casagandre apparatus and we fill this Casagandre apparatus by this soil sample. We plane the surface, top surface as much as possible. So it is done. Now this is the Casagandre grooving tool. Generally we cut the soil at the middle of this by a gentle push, just like so. Now we initially, this is the measurement of blow, the number of blow we measure. We measure the number of blow till this two part of the soil add with each other up to a length 1.125 centimeter. So start the blow. So it is clearly visible that approximately 1.125 centimeter of soil sample has been close to each other. So we take the reading of the blow and this is 27. So for the water content 20%, the number of blow is 27. this is our initial reading. Now we change the water content value and we repeat the test for a different water content, and we take the reading of another blow corresponding to that water content. So this is the soil sample, 300 gram soil sample, and we add more 10% of water. So this is 30 ml. It is clearly visible that after adding more water, the flowability of the water is more, and this is basically the flowability of the soil is basically the consistency. So add water and mix it properly. So again we fill the soil to this Casagander tool. So now we try to plane the surface. Now see it carefully. The initial reading was 27. There is two procedure to take the second reading. The first one is you start blow from this 27. So you have to calculate the second. Suppose the 50 blow has been come. So the second blow reading is 50 minus 27. But in this case, for the ease of calculation, we set this reading to 0. Okay, so 0. Now this is the grooving tool. Again we cut. And we start to give the blow gently. 2, 3, 4. So clearly we have seen the soil had been attached approximately 1.125 centimeter, and it is occurs after taking the 25 number of blows. So now our test has been almost completed. So initially, as we know that for the which water content at 25 number of blows, the soil has been attached to each other in the Casagrande tool is the liquid limit of that soil. So in this test, the liquid limit is approximately 30% for the soil sample.